wanna be the best in the game, invest in my name, check no restraints, I'm obsessed with the pain. I ingest, I retain, assess and I change, possessed by the thought I'll be free one day from society's restraints, money, clout and fame, mud, disease, a plague we all love to hate.
Hello guys and welcome. My name is Walid Abdullah and today my topic is optical computing. So what is optical computing? With the growth of computing technology, the need of high performance computer HPCs has significantly increased. The optical computing was a hot research in 1980s, but the work tapered due to material limitation. Using light instead of electric power for performing calculations, this choice is motivated by several features that light has. It is very fast, actually the fastest thing that we know. Speed is exactly that we need for our computers. It can easily be manipulated, divided, transported, delayed, split, etc. It is very well suited for parallelization. So, optics for computer. So, to make computers faster, their component must be smaller and therefore we should decrease their distance. This has resulted in the development of a very large-scale integration VLSI technology, but they are limited only to the speed of electrons in a matter, but also by increasing density of interconnection necessary to link the electronic gates on microchips. One of the theoretical limits on how fast a computer can function is given by Einstein's principle that signal cannot travel faster than the speed of light. The optical computing comes as a solution of miniaturization problem. So, let's talk about the features of optical computing. Optical interconnections and optical integrated circuits have several advantages over the electronic counterparts. They are free of electronic short circuits. Optical data processing can perform several operations in parallel much faster and easier than electrons. They are compact, lightweight, and inexpensive to manufacture. Computing is that optical data processing can be done much easier and faster. Optics has a higher bandwidth capacity over electronic, which enables more information to be carried out. So, optical computer. An optical computer, also called a photonic computer, is a device that uses photons, invisible light, IR infrared beams rather than electric current to perform digital computations. An optical computer, besides things are much faster, an electronic one might also be smaller. Bright flashes of laser beams can be sent hundreds of miles along fine strands of specially made glass or plastic optical fibers. Instead of transistors, such computers will have transphasers. There are switches that are activated by beams of light rather than the pulses of electricity. And unlike transistors, transphasers can build to handle several incoming signals at once. Beams of light can crisscross overlap each other without being mixed up, whereas the crossed electric current would get hopelessly confused. So also the arrangement of connections and switches would have to be flat, as in electric computer. It could be placed in any direction in space, allowing totally new design information processing. So optical fiber cables are made of glass or plastic, as you can see in the diagram above. So these are the old-fashioned and retro silicon machines. So let's talk about the merit. Optical computing is at least 1000 to 100,000 times faster than today's silicon machines. Optical storage will provide extremely optimized and safe way to store data, with space requirement less than today's silicon chips. Super fast search through databases. No short circuits, light beams can crisscross each other without interfering each other's data. Higher performance, higher parallelism, and less heat is released. Less noise is also made and more flexible in layout. There are very less loss in communication. So, what are the drawbacks of optical computing? Today's materials require much high power to work with consumer products. Coming up with the right materials may take 5 years or more. Optical computing uses a coherent source, is simple to compute and understand, but it has many drawbacks like an imperfection or dust on the optical components will create unwanted interference patterns due to scattering effects. Optical component and their production is still expensive rather than the silicon ones. New expensive high-tech factories have to be built. So what are the future trends of optical computing? Future trends. The Ministry of Information and Technology has initiated a photonic development program. Under the program, some funded projects are continuing in fiber optic high-speed network exchange systems. Research is going on for developing new laser diode and photo detectors and non-linear material studies for faster switches. So that puts an end to our video. So let's talk about the conclusion. Research in optical computing has opened a new possibility in several fields related to high performance computing. It's high speed communication to design algorithms that execute applications faster than the specific properties of optics must be considered, such as their ability to exploit massive parallelism and global interactions as electronic and smart pixel devices. Mature software development will have major impact on the future, and ground rules for computing and have to be written. Thank you for watching. If you like my video, please like and subscribe.